Hello everyone. In this video I am going to demonstrate power line communication. I am using high frequency signal on a DC line. My DC line is a 12 volts DC bus and my high frequency signal is a 45 kHz AC signal from an oscillator. I am using 555 timer as an oscillator. First I am going to describe the block diagram of the circuit. As you can see here, there is an oscillator. I am using 555 timer in oscillator block. The oscillator output is driving a power device. I am using IRF 840 as a power MOSFET. The output of the power device goes to a ferrite core transformer, ring core transformer. So here you can see this is the ring core transformer. This is the power device and here is the oscillator. So the output of the power device goes to a ring core transformer. So this is the ring core transformer. The primary of the ring core transformer is supplied with 12 volts DC and connected to MOSFET drain. So as you can see, the secondary of the ring core transformer is a center tap transformer. The winding is a center tapped winding and the center tap is connected to plus 12 volts DC. So as you can see here, this is the center tap line connected to plus 12 volts DC. So this is the plus 12 volts DC rail and it is connected to the center tap is connected to plus 12 volts DC. As you can see, the other two wires are forming the communication loop. So they are forming the communication loop. So as you can see here, this is the communication loop. These two black colors, these are power line communication. So basically power will flow in these two lines as well as communication data will also flow in these two lines. So whatever signal I am giving from here will be transferred from these two lines. You can see will be transferred from these two lines and will be received here on this transformer. You can see the dotted line means it is a long distance line. For me here it is a 1 meter wire. As you can see, it is a 1 meter wire for me. Just I have kept like this. So from the secondary of the transformer it is coming, as per the diagram you can see, it is coming to where? It is coming to another ring core transformer. See, on another ring core, second ring core transformer. So this is TX1, this is TX2. So let me draw it. This is TX1, this is TX2, transformer 2. So on the secondary of this transformer, again there is a center tap. So this is the second ferrite core transformer. As you can see here, this is the second ferrite core transformer. So those two wires, they are coming like this and they are coming to this ferrite core transformer like this, the two black wires. The center tap, you can see the center tap of this ferrite core transformer goes to a rectifier. AC-DC converter. AC-DC converter means a rectifier. So you can see here the center tap. This is the center tap of this transformer. It is going to this Schottky diode. Let me show you like this. It is going to this Schottky diode. This is the Schottky diode here. It is between the filter capacitor. That's why not clearly visible. So let me remove this wire a little bit. Now you can see this is the Schottky diode and here is the filter capacitor. So from here we can get the DC output. So that means I have pumped in DC plus 12 volts DC and here I will get some DC based on the transformation ratio. So I am getting 30 volts DC signal. You can see here I am getting a 30 volts DC because I have a trans ratio more. I am amplifying this DC. You can see. So this is the DC output. From here is the DC output. But whatever signal I am feeding from this oscillator is coming here. You can see this is the, you can see this is the primary winding of the transformer. So on the primary winding I have just connected an LED. So this LED will be glowing based on this frequency. So you can see here, this is the load LED. This LED is connected to the primary of this transformer. You can see. So from this oscillator data is coming, and finally data is coming out on the power line. So let me demonstrate now. I am going to stop the oscillation here. When I am stopping the oscillator, you will see here the LED will be off. You can see now LED is glowing. So I am stopping the oscillator. Once I stop the oscillator, you can see LED is off. I am starting the oscillator, on, off, on, off, on. You can see here, on, off, on, off. See, I am starting the oscillator, stopping the oscillator. So here you can see when I am starting the oscillator, stopping the oscillator, the LED is changing. So from here we can sample out the data. So like this, we can make a power line communication using high frequency AC signal on a DC line. Thanks a lot. Thanks for watching. This circuit is under development and under test. I will publish further videos on this topic. Thanks a lot. Thanks for watching.